Today we're starting a new unit on compositions of functions and inverses of functions. Today we will be talking about composition of functions. By the end of this video, you should be able to perform function operations and be able to find the composition of functions and determine the domain restrictions. Let's start with function operations. For these four problems, you will be using the two equations that are given at the top. F of x is going to be x plus 1, and g of x is going to be x squared minus 2x minus 3. We're going to add, subtract, multiply, and divide these functions. Question number 1 tells us to add f of x and g of x. So f of x is x plus 1. We're going to add g of x, which is x squared minus 2x minus 3. Now we just need to combine our like terms, and we end up with x squared minus x minus 2. And that's it. For the second problem, we're going to do g of x minus f of x. So we're going to start with g of x. And then we are going to subtract f of x. The important thing with subtraction is to remember to distribute the negative. So we end up with x squared minus 2x minus 3 minus x minus 1. And then you combine your like terms and end up with x squared minus 3x minus 4 as your final answer. Next, we're going to do a multiplication problem. We have f of x times f of x. You can combine a function with itself. It does not have to be combined with a different function. So we're going to take f of x and multiply it with f of x. So we end up with x plus 1 times x plus 1. And then we just double distribute. X times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. So our final answer, when you combine your like terms, is x squared plus 2x plus 1. Now, division is where it can get tricky. We have g of x divided by f of x. So g of x is x squared minus 2x minus 3. We are dividing by f of x, which is x plus 1. When you divide, you have to cancel factors. You cannot simplify individual terms. So for example, you cannot take negative 2x and divide by x and end up with negative 2. That does not work. You have to factor the numerator first. So if we factor x squared minus 2x minus 3, we need to find two numbers that multiply to negative 3 and add up to negative 2, which in this case is negative 3 and positive 1, because negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So now, since both the numerator and denominator have an x plus 1, we can cancel those because they are factors. And we're left with x minus 3 as our final answer. So that is function operations. We could be adding, subtracting, multiplying, or dividing two different functions or a function with itself. Now we're going to look at evaluating functions, and this will lead us into compositions. First, we're going to take f of 2 and add that to g of negative 2. So f of 2 means we're going to take f of x, which in this case is x plus 1, and we're going to plug 2 in for x. So we have 2 plus 1. So we're going to take 2 and plug that in for x. Then we're going to add that to g of negative 2. G of x in this case is x squared minus 4. So we're going to plug negative 2 in for x. And then we just simplify. So we have 2 plus 1, which is 3. Then we have negative 2 squared, which is 4, minus 4. When you combine all of those, you just end up with 3. The next problem has us find f of b. So we're going to do the same thing. We're going to plug b in for x. So instead of writing x, we're going to write b. We can't combine these terms, so all we can do for our final answer is write b plus 1. Now let's try one that's a little bit trickier. We're going to find f of x plus 2. So we're going to plug x plus 2 in for x. Then we can combine our like terms, and we end up with x plus 3. This is essentially composition of functions. You are plugging one function in for x in another function. First, we have a definition of domain. For h of x equal to f of g of x, this is how we typically write a composition. You read this as f of g of x. The domain of h is the set of all x values such that x is in the domain of g and g of x is in the domain of f. So let's take a look at an example. For these next two problems, we have that f of x equals 3x minus 2 and g of x equals x squared. So we want to find f of g of x and then find the domain of that function. So f of g of x means we are going to plug g of x into f of x. So I'm going to start with f of x, which is 3x minus 2, and I'm going to plug g of x, which is x squared, in for x. And then you simplify this, which all you can do to simplify is just say 3x squared minus 2 is your final function. When we look at the domain, this definition says we have to look and see what x values are in the domain of g. So if we look at g of x, this is x squared. This is a polynomial. Hopefully you remember from our polynomials unit that the domain of every polynomial is all real numbers. So there are no domain restrictions. Then we need to look at what outputs of g of x are in the domain of f. So again, we need to look at the domain of f of x. This is a linear function, which again is a type of polynomial, so its domain is all real numbers. So since we don't have any domain restrictions on either f of x or g of x, our domain of the composition, f of g of x, is going to be all real numbers. So you can write it in interval notation as negative infinity to infinity, or you can write it in set notation. It's the set of all x's such that x is an element of the real numbers. Number 9 asks us to find g of f of x. So we're taking f of x and plugging it into g of x. So I'm going to start with g of x, which is x squared, and then I'm going to plug f of x in for x. Now, you know that when we square a binomial, we need to write it out twice and double distribute. So 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is negative 6x. And negative 2 times negative 2 is 4. Then we just combine our like terms and end up with 9x squared minus 12x plus 4. Again, we need to find the domain of this function. We already said that the domain of both f of x and g of x is all real numbers. And we end up with a polynomial as our final answer, which also has a domain of all real numbers. And again, you can write it in either interval notation or set notation. Let's take a look at another example. For these next two problems, we have that f of x is 2 over x, and g of x is x minus 2. So again, we're asked to find f of g of x and its domain, and then g of f of x and its domain. So for the first problem here, we're going to take g of x and plug it into f of x. So I'm going to start with f of x, and I'm going to put parentheses where the x is, and then I'm going to plug g of x into x. So I end up with 2 over x minus 2 as my answer. You cannot simplify it. When we look at the domain, think about fractions and about division. What is the only number that you are not allowed to have in the denominator? You are not allowed to divide by 0. So, if we look at this, we have to figure out what number, when you plug it in for x, will make the denominator 0. And we cannot plug that number in for x. So if you look at the denominator, we have x minus 2. If I want to know what will make the denominator 0, I can set that equal to 0 and solve. And I get x equals 2. So if I plug 2 in for x, I will end up dividing by 0, which is not allowed, which means our domain is everything except for 2. So we can write this either in interval notation as negative infinity to 2, union 2 to infinity, or in set notation, it's the set of all x's such that x does not equal 2. Let's take a look at the next problem. We have g of f of x. So we're going to plug f of x into g of x. So I'm going to start with g of x, put parentheses where the x is, and then I'm going to plug f of x in for x. So here I get 2 over x minus 2. Now if you want to combine these terms, you can find a common denominator and subtract the fractions, but I'm not going to require you to do that at this point. We'll get to that in our next unit on rational functions. So for right now, this answer is fine. Let's take a look at the domain. Again, we have a fraction, and we are not allowed to divide by 0. So, what value for x would make you end up dividing by 0? If you take the denominator, you set it equal to 0 and solve, you get that x equals 0. So we can have any number other than 0. So we can write that in interval notation or in set notation. So the two types of functions that you need to be careful of are rational functions, which are fractions, and radical functions. We discussed in the last unit that whenever you have an even index radical, square root, fourth root, sixth root, that it can never equal a negative number. So the stuff inside the radical has to be greater than 0. So when we're talking about compositions, the two different types of functions that will have domain restrictions are rational functions, which are fractions, because you're not allowed to divide by 0, and radical functions, because an even index radical has to have a radicand that is greater than or equal to 0. Let's take a look at another example. Here we're going to evaluate compositions. So we're given that f of x equals 5x minus 2 and g of x equals x squared minus 4. In this first problem, we're asked to find f of g of negative 2. So if you think back to when you learned about function notation, if you had g of negative 2, that means you are plugging negative 2 in for x in g of x, and you end up with a number as your answer. So when we're talking about compositions, you're going to start by doing that. You're going to find g of negative 2. So if I start with g of x and then plug negative 2 in for x, so this is g of negative 2. Negative 2 squared is 4, minus 4 is 0. Then I'm going to take that answer and plug it in to f of x. So I'm going to find f of 0. So 5 times 0 is 0. Minus 2 gives me negative 2. So our final answer will be negative 2. So when you are evaluating compositions, you need to start in the innermost parenthesis and work your way out. So for this next example, we're going to start with 4 and plug that into f of x. So 5 times 4 is 20, minus 2 gives us 18. Then we're going to take that answer and plug it in for g of x. So we end up with 18 squared minus 4. So 18 squared is 324, minus 4 gives us 320. For this last example, we have g of 3. So I'm going to start in the innermost parenthesis, which is 3, and plug that in for g of x. So 3 squared gives me 9, minus 4 is 5. Then I'm going to take that answer and plug it in to g of x again. So if I have g of 5, 5 squared is 25, minus 4 is 21. So that is our final answer. Compositions takes a little bit of practice to get used to, but essentially you are plugging one equation into another.